In this video, you add shelves to a bookcase family using a nested component. A series of family parameters are then created and the values are driven from formulae to control the shelf widths, quantities, and spacings. Finally, you create and control the parametric array using a family parameter. Powerful and intelligent families can be created with the use of formulae to control dimensions and other types of data. In the example shown, our bookcase requires a number of shelves which will be equally distributed. The user can then input the required number of shelves and Revit will then generate an array and space the shelves using a series of formulae. The brackets within the formulae control the order of calculation. So in the example of the shelf width, the material thickness is multiplied by 2 and then the width is subtracted. We'll begin by opening the family. On the Revit home screen, select Open. In the Open dialog box, let's select Bookshelf and select Open. Our first task is to create some additional parameters to control the shelf positions, including things like the shelf width, the shelf spacing, and the number of shelves. To do this, on the Create ribbon in the Properties panel, let's go ahead and select Family Types. We'll now generate some additional parameters. To do this, on the bottom of the dialog, let's select New Parameter. In the Parameter Properties dialog, we'll begin by creating a parameter to control the number of shelves. So let's type in number of shelves. This will be a type parameter. The discipline is set to common. The type of parameter is not going to be a length, but it will be an integer. This is quite important as we only want the user to enter whole numbers. And finally, we'll group the parameter under dimensions. We'll then go ahead and select OK. Notice that the default value for our number of shelves is now 0. This will cause formulae to fail, so we have to give this a realistic default. Let's make it 3. We'll now generate our second parameter, which will control the shelf width. Again, we'll select New Parameter. And for the parameter name, we'll type in shelf width. Again, this will be a type parameter. And it's a length, and we'll group this under dimensions, so we can select OK. And our final parameter will be the shelf spacing. So once again, in the Family Types dialog, we'll select New Parameter. And we'll enter in shelf spacing for the parameter name. And again, this will be a type parameter. It will be a length, and we'll group this under dimensions. We can then select OK. We're now ready to generate some formulae. Both the shelf spacing and the shelf width will be controlled by formula. You'll notice that currently we're looking at the value column with all of the actual values of our parameters, but just to the right of that we have a formula column where we can write formula based on other values. Let's begin with shelf width. So this formula will be based on the width of the overall carcass. So let's start by typing in width. We then want to subtract twice the material thickness. So we'll put in the subtract symbol, and then what we want to do is multiply the material thickness by 2 and then subtract it from the width. To ensure that this calculation happens first, we'll enclose it in brackets. And of course, for the multiply value, we use the asterisk symbol. Let's now select Apply in the Family Types dialog, and we can now see that the shelf width has been calculated. We'll also create another formula to control the shelf spacing. Similar to the shelf width, the shelf spacing is going to be controlled by the overall height of our carcass. So we'll begin by typing in height. And in this case here, we want to actually divide it by the number of shelves. But actually, what's going to happen is we'll have 3 shelves, and we're actually working out the space in between the shelves. So if we have 3 shelves, we'll have 4 spaces. So we're going to divide it by the number of shelves plus 1. So again, we'll enclose this in brackets so that this calculation is done first. So let's say height divided by, and then we can type in number of shelves plus 1. And again, if we select Apply, we can see that calculation update. So now that our parameters are created and our formulae are written, we can now go ahead and say OK to the Family Type dialog. Next, we'll create a reference plane that's going to host our new shelf. To do this, we'll open up an elevation called Placement Side. So in the project browser, under Elevations folder, let's open up Placement Side. We'll now generate our additional reference plane. On the Create ribbon in the Datum panel, let's select Reference Plane. We'll now sketch a new reference plane. We'll sketch it approximately in this location, and of course the actual value of this will be driven by our formula. It is very important to actually give this reference plane a name, because we will need to use this as a work plane when we host in our shelf. So let's name this shelf. We'll now apply our shelf spacing parameter to this. So first we'll need to create an aligned dimension. On the context ribbon in the measure panel, let's go ahead and select aligned dimension. We'll then place a dimension from this top reference plane here to this reference plane that we've just created. We'll press escape twice to exit the dimension command. We'll then select our newly created dimension, and on the label dimension panel, we'll go to the label pull down menu and we'll select shelf spacing. We're now ready to place in another component, which is going to be our shelf. We'll then associate the parameters and then finally drive that with an array. To bring in the shelf, we'll open up the floor plan. So in the project browser, under the floor plans folder, let's open up reference level. To place our new component, we'll select the create ribbon, and on the create ribbon in the model panel, we'll select component. Revit then prompts us to load a new family, so we'll select yes, and we'll select the panel family and click open. We'll now notice that we have the panel on our cursor. If we take a look onto the context ribbon, we can see that place on work plane is the default value. On the options bar, we can change the placement plane, and here we'll select our named reference plane called shelf. We'll then place down the shelf approximately here. We're not going to snap here because we need to make sure that this is constrained to the correct reference planes. We'll now align this to the reference planes. To do this, on the context ribbon in the modify panel, let's go ahead and select align. We'll begin by selecting this reference plane here, and then the edge of our shelf. And then we'll select this reference plane here on the front of the wall. Now we may need to use the tab key. We can then select the reference plane and the back edge of our shelf. We'll now press escape twice to exit the align command. And now we'll toggle the view back to the placement side elevation. Of course, we can now see our newly placed shelf in position. Next, we'll create an array of our shelf and our reference plane. Let's first select both of these components. I'm going to use a standard Revit selection window to select the reference plane and the shelf. On the context ribbon in the modify panel, we'll then select array. On the options bar, we'll just check that this is set to a linear array. We'll leave the default number set to 2, and we'll move to the second position. So the move start point will be the top of this reference plane here, and the move end point will be this reference plane here. We'll then press escape to deselect the array tool. We'll select the array, and on the options bar, we can then assign this to a label. In this case, we'll assign this to number of shelves. What we now need to do is ensure that the distance between these two items here is the same shelf spacing. To do this, on the context ribbon in the measure panel, we'll select aligned dimension. We'll place another dimension between these two reference planes here. We'll press escape to exit the aligned dimension command. We'll then select our newly placed dimension, and on the label dimension panel in the label drop-down menu, we'll once again assign shelf spacing. Currently, the nested shelf hasn't actually had its parameters associated. That means that if we change the shape of the carcass, the shelf will remain unchanged. So we'll need to do that now. So we'll move over the shelf. Of course, this is in an array group, so we'll press the tab key to select just the shelf itself. In the properties palette, we'll select edit type. And we can now see the various type parameters controlled in the panel depth, thickness, and width. Let's begin by associating the panel depth. So we'll click Associate Family Parameter, and this is going to be equal to depth. We'll then associate the panel thickness, and this will simply be associated to the material thickness, so that will match the carcass thickness. And finally, the panel width we'll associate, and this one will be associated to shelf width, which is driven by the formulae we wrote earlier on. We'll then select OK. One final consideration to make is that our array is not constrained in the horizontal axes. Let's go ahead and select the array group, and then on the cursor pad, press the right or left arrow, and you can now see that we're able to actually nudge these shelves to the left or the right. We must ensure that these are constrained. To do this, on the Modify Context ribbon in the Modify panel, we'll select Align. We'll begin by selecting this reference plane here, and then we'll select the edge of the shelf. Again, you can now see that that's aligned and automatically constrained. We'll press Escape twice to exit the Align command, and we'll now toggle the view back to our View 1, which is our 3D view. We're now ready to test our bookshelf, so let's zoom up, and we'll then go into the Family Types dialog. To do this, on the Modify ribbon in the Properties panel, we'll select Family Types. We'll just reposition the Family Types dialog, and we can now test our various different parameters. Let's begin with number of shelves. I'm going to increase this to 5 and then select Apply. We can now see that the shelf count has indeed increased. We'll then change the height from 5 feet to 6 feet and once again click Apply. We can clearly see that the shelves have redistributed based on our formulae. Finally, we'll set a new width for our bookshelf. Let's amend this to 4 feet. And again, we'll select Apply. Let's click OK to the Family Types dialog, and we can now see how important formulae are to add intelligence into our Revit families.